Good morning, children. Today we are starting our online class. I hope you all are fine. You can keep a notebook and a pen with you. You can note down the points, what all things we are discussing. Today we will discuss the chapter 12, areas related to circles. In this chapter, we shall begin our discussion with a review of a concept of circumference and area of a circle. We are applying this knowledge in finding the area of two special parts of a circular region known as sector and segment. We all are familiar with the circle and its related terms.
In this chapter, we will discuss about circles and its related terms, concept of perimeter and area of a circle, finding the area of sector and a segment, and also find the area of some combinations of plane figures involving circles or their parts. A circle is the collection of all the points in a plane which are at a fixed distance from fixed point. That fixed point is known as the center of the circle.
The fixed distance is known as the radius of the circle. Here O is the center of the circle and OP is the radius of the circle.
The distance between any two points on a circle is known as the chord of the circle, and the chord which passes through the center of the circle is called a diameter of the circle. A diameter of a circle is the longest chord of the circle. Here OR is the diameter of the circle and PR is the chord of the circle. We know that an arc is the piece of circle between 2 points. In this figure, PQR is the major arc because it's a longer one, whereas PR is the minor arc of the given circle. Now we are talking about the segment of a circle. The region between a chord and the corresponding arc is called the segment of the circle. A part of a circle is known as the sector. That means the region between two radii and the corresponding arc is known as the sector of the circle. These are the related terms of circles. You have studied perimeter of a circle in your earlier classes. The distance covered by traveling once around a circle is called its circumference. We know that the ratio of circumference and the diameter of a circle is a constant value. That constant value is almost equal to 3.14 or 22 by 7. This constant ratio is denoted by the Greek letter pi. So, circumference by diameter is equal to pi. Therefore, the circumference is equal to pi into diameter. That is equal to 2 pi r, where diameter is equal to double of the radius. Therefore, the circumference of a circle is equal to 2 pi r. Also, we know that the area of a circle is pi r square, where r is the radius of the circle. Let us see some more useful results. Area enclosed by two concentric circles. If capital R and small r are radii of two concentric circles, then area enclosed by the two circles is equal to pi r square minus pi small r square. In both the terms pi is common, you can take it out, then that is equal to pi into r square minus r square. Here you can see there is an identity a square minus b square, third identity of. So we can expand that pi into r plus r into r minus r. We know that a square minus b square equal to a plus b into a minus b. So if you know the radii of two concentric circles, we are able to find the area using this formula. That means the area enclosed by the two circles, pi r square minus pi small r square. That means that the area of the larger circle minus area of the smaller circle, then only we are getting the area of the shaded region. If two circles touch internally, then what will be the distance between the centers? The distance between the centers is equal to the difference of their radii. Same way, if two circles touch externally, then the distance between their centers is equal to the sum of the radii. See one more useful result. The distance travelled by a rotating wheel in one revolution is equal to the circumference of the wheel. So the number of revolutions completed by a rotating wheel in 1 minute is equal to distance moved in 1 minute divided by circumference of the wheel. Now let us do some problems related to this concept.
The radii of two circles are 19 centimeter and 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of the circumferences of the two circles. Here, the radii of two circles are given. One is 19 centimeter and another one is 9 centimeter. We want to find the radius of the circle which has circumferences equal to the sum of the circumferences of the two circles. So, the first circle, the radius we can mark it as R1, that is equal to 19 centimeter. Second circle, the radius is equal to 9 centimeter. We want to find the radius of another circle. The circumference of that new circle is sum of the circumferences of these two circles. If the radius is 19 centimeter, we know that the circumference of this circle is 2 pi r1. That is the radius of circumference of this circle is 2 pi r1, and radius circumference of this circle is 2 pi r2 because the radius is root r2. Sum of these two circumferences equal to circumference of the another circle. So there will be another circle with radius r. Sum of these two circumferences is equal to the circumference of this circle. So that is circumference of this circle is 2 pi r because the radius is r. If when the radius is r centimeter, the circumference of the circle is 2 pi r. Now we know that the radius of this circle and this one, we can find the circumference of these two circles. So 2 pi r1 plus 2 pi r2. In both the terms, 2 pi is common. You can take it out. So it will be 2 pi into r1 plus r2 is equal to 2 pi r. Now 2 pi into the radius r1 is equal to 19 plus r2 is equal to 9. 19 plus 9 is equal to 2 pi r. We want to find the radius of the circle. So radius is equal to 2 pi into 19 plus 9 divided by 2 pi. Take this 2 pi to this side, transpose this term 2 pi to this side, then it will be 2 pi into 19 plus 9 divided by 2 pi. 2 pi and 2 pi is cancelled. So radius is equal to 19 plus 9, that is equal to 28 centimeter. The wheels of a car are of diameter 80 centimeter each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at a speed of 66 km per hour? Here, the diameter of the wheel is given for you and the speed of the car also given. The diameter of the wheel is equal to 80 centimeter and speed of the car is equal to 66 km per hour. That means the distance travelled by the car in 1 hour is equal to 66 kilometer. Distance travelled by the car in 1 hour is equal to 66 kilometer. Therefore, the distance travelled by the car in 1 minute is equal to, because 1 hour means 60 minutes. So, distance travelled by the car in 1 minute is equal to 66 by 60 kilometer. Therefore, the distance travelled by the car in 10 minutes is equal to 66 by 60 into 10 kilometer. For 1 minute, 66 by 60 kilometer. Then for 10 minutes, 66 by 60 into 10 kilometer. That is equal to how much? 0, 1, 10 is cancelled. In 6, 11, 6 are 66. So it will be equal to 11 kilometer. But we know that the diameter is given in centimeters. So you have to change this kilometer into centimeter. First we can change the kilometer to meter. Then it will be 11,000. That is 11 into 1000. Again, this is the meter. Meter change it to centimeter. 1 meter is equal to 100 centimeters. So this much meter is equal to into 100. So this much centimeter we got it. 11 into 1000. That is 11,000 into 100. That will change it to centimeter. So you don't need to multiply. You can keep it like this. Then after when last you can calculate it. When that time it is easy for to calculate. You can keep this way. Now we know that the diameter of the wheel is equal to 80 centimeter. Therefore, the radius is equal to 40 centimeter. We know that the distance moved by a rotating wheel in one revolution is equal to the circumference of the wheel. So, we can find the circumference of the wheel. That is equal to, circumference of the wheel is equal to 2 pi r. That is equal to 2 into 22 by 7 into radius. That is 40 centimeter. That is equal to 80 into 22 by 7 centimeter. You don't need to multiply now. Last step we can multiply. You can use the cutting method. So making our calculation a little more easy, keep it like this itself. So I'll repeat once more. The radius of the wheel is equal to 40 centimeter and the distance moved by a rotating wheel in one revolution is equal to the circumference of the wheel. So the circumference of the wheel is equal to 2 pi r. That is equal to 2 into 22 by 7 into 40 centimeter. 2 into 40, 80. Keep this 22 like that. No need to multiply now. So 80 into 22 by 7 centimeter. So the number of revolutions made by the wheel in 10 minutes is equal to number of revolutions made by the wheel in 10 minutes is equal to distance travelled by the car in 10 minutes divided by the circumference of the wheel. That is 11 into 1000 into 100 centimeter divided by 80 into 22 by 7 centimeter. That is equal to 11 into 1000 into 100 by 80 into 22 by 7. will be into 7. Take the whole divided by 7, that will be, division will be changed to multiplication. Centimeter and centimeter will be cancelled. That is equal to, here 1 0 is cancelled, and here it is 10 and 8, there will be a common factor 2, so 4 times here, 5 times 1 11 is 11, 2 11s are 22, so 5000 into 7 divided by 4 into 2, that is equal to 35,000 divided by 8, that is equal to 4,375 revolutions. So the number of revolutions made by the wheel in 10 minutes is equal to 4,000 each wheel in a car. That is equal to 4,375.